All right, welcome everyone. It's about time, so we'll go ahead and get started. Web Security 101. My name is Michael Peters. I work for a company called +3 where we do a lot of online fundraising for nonprofits and political groups. Security is very important to us because we deal with a lot of money and almost all of it's not ours. On IRC, if you find me, M. Peters, I have a really creative IRC name. So this talk is specifically geared towards developers. There are a class of web security web security problems that affect sysadmins and how you set up your system and how you do that securely. I'm not really going to focus on those. Some of them I'll kind of mention because there's some overlap. But most of what I'm going to be talking about is developers, so code and how you do your code. The primary thing to understand for web security is you do not control the client at all, whatsoever. Any input is automatically assumed to be evil. You really need to think of it as being everything you could possibly get from the HTTP request could be evil. So we're talking the URL, GET post parameters, cookies, HTTP headers. Don't trust any of it. And don't ever make your front-end security, like your form validation. It's fine to have that in JavaScript. It's nice and responsive to do it early on in JavaScript, but do not rely on that for your security. Because it can be bypassed. Now there are some security problems that browsers do take care of, and that you do actually have to mitigate through JavaScript. But those are slightly different, and we'll get to those as we get along. Be very strict on your validation, as strict as you possibly can. It's a constant battle to fight with users and product owners as to how strict you want to be and how lax you want to be, because the stricter you are, usually the less user-friendly you are, but also the more secure you are. So it's always a balance, and you have to find the right balance for your product. But as a general rule, whitelist, don't blacklist. So come up with a list of things, we accept these, and everything else is bad. Because if you go the other way, there's always something else to add to a blacklist. And there are no easy solutions. You have to think about security. You have to have that in your mindset. There's not just a security layer you can stick in front and go, okay, well, we're done. It is a end-to-end thing, so you need to think about it the whole way. You should know the tools you're using. Some languages are more secure than others. Some languages have a better track record for security. There are some languages, PHP, that will release known security flaws after people point them out, and will release them anyway. So I don't quite understand that, but Perl has an excellent track record for security. So we're in good hands there with P5P. They really take security seriously. And think about other things you use, your database vendors, your entire stack. Think about how their track record is in security. If you're involved in the decision making of buying something new, find out about their track record of security. So talking about some of the common kinds of attacks and how we can mitigate against those and protect. These are the ones we're going to go through. Code injection, which has a whole class of things involved. So system commands, SQL injection, HTML injection, JavaScript. Then we'll talk about cross-site scripting, cross-site request forgery or CSRF, denial of service attacks, buffer overflows. Those are sort of the older more common ones, or older, less common nowadays. But some of these are kind of tricky and can take a little bit of time conceptually to understand how they work. So if you have any questions, please raise your hand to understand the flow of an attack, because you can't prevent the attack if you don't understand how it happens. So a very basic example of system commands. Say you want to create a file based on some user input. So in this case, we're having a user upload an image, and we allow one photo per person, so we can just use the user's ID. The user's logged in, we know that, so they give us their user ID and we save the image as that. And this falls apart if they pass something like this as their user ID. Now, for all my examples I'm going to show, that's in URL encoded, and most people don't automatically URL decode things in their head. So all my examples are going to show unencoded. But think about it, they will be encoded, so it's not immediately recognizable when you see it what happens. So what happens here when they pass this as a user ID? They overwrite your password file, right? And if they're smart enough, in whatever file they uploaded a new password file. So now they have overwritten your password file with something else that they wanted. So going further along this, not just opening a file or using it as a file name, but Perl does system commands through lots of things. System, exec, backticks, QX, open, as we saw earlier with file names, but open also can be used to execute commands, if you're not familiar with that. So in this case, same thing, passing the user or the path to this picture that we created using partial user data for that and running it through ls. Obviously, there's better ways to get information about the file than ls, but just as an example, and if they pass something like this, you have just emailed me your password file. Because now I can just stick a semicolon in there and then inject another system command. So the way to solve this is a couple ways. First, because we can't trust the user input, if we're going to be using anything inside of a file path, strip out all the upward stuff, the dot things that you saw for Unix anyway, make it go outside of a directory. So in Perl file spec, no upwards, we'll strip that out so that they can't reference something outside of what you're localizing here, and then put it onto a safe path that you can control in this case. Further than that, be very strict on what you're validating. If we had made sure that user ID was a number if we're using number IDs, or if we're using a SHA-1 hash or something, we can be strict in limiting what that input is going to look like, and we need to. Things get a little bit more complicated when you're just accepting straight data, like a blog post, which can contain anything, but we'll get to something like that in a second. So validate, early and often. In Perl, we have an extra little tool for this called taint mode, where you can turn on taint mode, and it will make sure that anything coming from outside of your program is never used for a system call. Now, taint mode is kind of old. It's not always well tested every time they make a new change to Perl core. So there are some releases of Perl that have a buggy taint mode where maybe taint mode affects the regex engine in weird ways. So make sure it doesn't cause problems for you. But if you turn taint mode on and you turn it on in your testing environment, you should be able to figure out most of that stuff if it's causing problems. But if you can turn taint mode on, I highly recommend it because it's a nice safety net that just keeps you from splatting on the floor and bursting out your guts everywhere. This is my turn to take a drink. Oh, yes, go ahead.
Oh, so yeah, I wanted to know, I mean, let's say that I trust everything, okay, now, maybe I should, let's say I trust everything on my server, but I just want to take everything that's coming to me through the web browser.
There's not really a good way to do that.
Is that a good idea?
I mean, yeah, in a way. I'm just trying to think how much you can really trust everything. Like if you're not going to trust your web input, there are probably other things on your system that you shouldn't totally trust either. Yeah, but there's not a current way in Perl to say just taint this I/O path coming from here. So moving on for other code injection, we're talking about SQL injection, and this is a very popular series of exploits that happen all the time currently in just about any web-based system. You'll see this all the time in a lot of open source CMSs or blogging engines or something. Some new SQL injection vulnerability comes out. But basically, it's taking user input, in this case the search parameter, coming from my query string, and sticking it inside of query that I'm building. And SQL injection can be used to delete data, like this. If I pass this as my search parameter, your database is hosed. It can be used to corrupt data. I can, make it do an update instead. Now, again, so these examples are kind of simplified because in reality, doing multi-statement executes through DBI doesn't quite work this way. But you can get around a lot of this stuff. I'm just trying to make the examples really simple so you can see what's going on. It can be used to steal data. So if you have a search criteria, for instance, searching for this name, and or even if your SQL statement says limit this to public data, like we have here, right, where it says public 1, well then I can just do an or public equals 0 in this parameter. And so if I know your data structures in the database and maybe how you're doing the security there, I can expose data that you didn't intend for me to see. Another interesting thing about SQL injection attacks is that it can be used to get data that you didn't aren't even exposing in the first place. So say I have a list of users in the system, or in this case, this is a login. So I'm trying to check if this password the user gave me is valid and they can log in. So I get the password and I'm going to do a comparison. I'll talk about passwords later too, but I'm going to get the password. But if they can do an SQL injection attack here, then they can do timing attacks where they can steal that password for users who aren't themselves. And if you're storing a hash instead of a password, then they can steal the hash and crack it offline based on the timing of the requests back and forth. Does that make sense? So just because you're not exposing the data doesn't mean it's not exposed to an SQL injection attack. So first, for SQL injection attacks, and PHP, just by the way that it has evolved as a language, is actually, it used to encourage very bad practices for this kind of thing, because they added, they tried to escape. So when the user passed into data, they would just try to escape it to make sure it didn't have any funny things that would affect the SQL query. So they had magic quotes, which didn't work quite right for SQL stuff. So they add slashes, which didn't work for different database engines. So they added MySQL escape string, which wasn't quite right. So MySQL real escape string. You see the pattern. It's hard to do, and it really depends on where the data is being used in various parts. In Perl, for a long time, almost since the beginning of DBI, we've had bind variables. So you put a question mark, and then when you execute, you pass that variable, and the database drivers know how to put it right into the question mark, make sure it doesn't contain bad things, it's quoted correctly, and all that kind of stuff. Yes?
Sorry, but that bind functionality has to be supported by the database itself.
Yes and no. It could be at the database level, or it can be also in the driver level. I think for MySQL, it happens at the driver level.
Okay.
Yes?
Except there are some times when bind doesn't work.
Well, right, I'm getting to that in just a second. There are times where it doesn't work. For instance, limit part, like if you're doing a limit, like if you're doing a page search query coming back, limit is one of those places that you can't use a bind variable. So, but limit has to be a number. So strictly validate that to be a number, and then you can safely include it in your query. Yes?
But it could be a bind variable that was done in the driver level?
That's a good question. I'm not totally sure on that. I don't know if there's any driver developers here at the conference to answer that question. But so PHP has that now too. I mean, I think their database DBO or something. They have a new database.
The MySQLi does bind also.
Right. Okay. So they have different interfaces for the databases that would do the bind variables as well.
It's not as easy to use as Perl.
No, it's not. So if you're not crafting your SQL by hand, you might think, well, I'm good. I have an ORM, or I have a tool that's going to build my queries for me, and I'm safe. I don't have to think about this. Mostly yes, but not totally. You still have to think about where this data is coming from, how it's kind of flowing. Does anybody see the security problem here? Just if you're familiar with SQL abstract, or even if you're not. Yes?
Potentially there's a problem if param can return a list.
Ah, exactly. Yeah. So the problem here is if param returns a list. For instance, if this is my query string coming in, I now have 3 search parameters instead of just 1. And param is set to return a list in list context if there's more than 1 coming through, which changes my structure to this. And then what happens in Perl? The last one wins, right? So it overwrites the public and then opens up that data, right? So you have to be thinking about the user data. And this one's pretty easy. It's again, knowing the library, knowing the interface, you put scalar in front of that, and then you're just going to get one value. And then SQL abstract will take care of making sure everything's bound correctly or escaped as it should be. All right, cross-site scripting, or XSS. So to understand how cross-site scripting works, basically, when you're using a web browser and there's JavaScript, JavaScript executes on behalf of the user. So it can make requests to the website using the cookies of that user, just as if the browser itself was making a request. And so the way XSS works is that somebody inserts some JavaScript somehow into executing for the user's behalf. In this case, for instance, if I included a script tag that includes a URL to some other site to pull in some information. And that could expose various things that JavaScript itself, if it executes, will execute on behalf of the user. And there's some browser security based, various cross-domain security walls that browsers put up with this, but if somebody can get JavaScript into your application, then it can get around that. And it exploits the user's trust in the site. They go to Amazon.com not expecting Amazon to steal information from them or to, because it's not Amazon, it's somebody else doing it on Amazon's behalf, but through Amazon. So any site that takes input from the user and it displays it in some way, even if it's not public-facing display, is susceptible to XSS. So a comment on a page, if I can put JavaScript in there, the person who comes to read that comment could get attacked. A petition form that sends a list of signatures. Contact form where it's not even then shown on the public side, but the admin then comes in and logs in and sees this. If I can inject JavaScript into like my name part of the field, I can get the admin's login credentials and things like that. And another tricky thing about XSS is that it doesn't have to actually be stored on the page itself. If the page uses some parameter from the URL to then customize the page, whether it happens on the back end or the front end, that is then acceptable. It can also give me an avenue for XSS attacks. So there's a couple of classes of XSS. Non-persistent, that's what I'm talking about, the URL. For instance, say Google used some parameter in the URL that you pass, maybe the query string or what you're querying, and then somehow displayed that on the page you're using and didn't strip out the JavaScript that might be there. That would let you craft a URL that puts JavaScript that executes on Google and attacks whoever clicks on that URL. And this would cause, it's also made much easier with things like the URL forwarding services that people use, like Bitly and other things, that people just randomly click on these links without knowing exactly where they're taking them to. So you can hide really long, complex, malicious URLs inside these little quick, short URL shortener services. And, people click on links all the time, a help link forum or something like that. I'm in a help forum. The other form of XSS attacks are persistent. So that is where the script is embedded in the site through a comment or something like that that's then shown. So if you're familiar, a few years ago, there was a MySpace worm, which was a result of this. Somebody figured out in their how to customize their MySpace profile, so their description, their user description, so to contain JavaScript. And what it did when you viewed this person's profile is it would then make you their friend, and everyone you had as a friend would then become their friend as well. And so it just cycled through this thing. He thought it would just be funny as a joke, and then it just basically brought down MySpace because everybody became his friend. But MySpace really did try to stop this kind of thing. They were thinking about this, and so they had things that would try to parse the script, because MySpace was accepting HTML and even some basic other stuff too. And so he found a way to trick MySpace parser into giving some JavaScript that wouldn't really be quite JavaScript, but that IE was lax enough to interpret as JavaScript. And so it executed for IE users, even though MySpace was trying to filter out the JavaScript. So that kind of thing is really hard to get right. If you can, don't ever take HTML from users. Do maybe something like a Markdown or some other format that you can then easily convert into an HTML. It's not always possible to avoid that, but that's the easiest way. We'll get to that in a second too. Yeah. So a DOM-based XSS is even more complicated because it's not injecting JavaScript itself, it's injecting data that then JavaScript on the page will execute, thinking that it might be plain text, but then do something weird with it. Now these are harder to explain and harder to find in the wild because you really do have to know how the back end is giving the data, storing the data, or not necessarily storing it, but how it's presenting the data back to, let's say, a JavaScript AJAX service or something like that. But a way to think about it is store some data that then gets presented as a JSON string or JSON structure to some web service that just blindly trusts the data. And you could, if you know how that JavaScript is going to execute it, then you can do some weird things. DOM-based XSS attacks exposed a common misbelief that a lot of people had about XSS, that you could prevent XSS solely by trying to escape it before you stored it. So you can just get rid of HTML, escape everything, and you're good to go. But that it doesn't work because of these DOM-based things, which aren't HTML exactly. It's JavaScript worked around anyway. But the problem is that it also makes your data bad if you needed to ever use it in non-HTML context. So PDFs, spreadsheets, that kind of thing. So to fight XSS attacks, if you're dealing with non-HTML, validate it as you receive it, store it the way they gave it to you as best you can, maybe clean up the date and other things like that, but store the data that they gave you and then always escape it on the output. So always make sure any HTML characters are escaped when you show it to them, not necessarily when you're storing it. And you need to escape in different contexts. There's HTML escaping, there's URL escaping, JavaScript escaping, CSS escaping, which is hairy. But just as a quick example, if you're in Perl and you're using HTML template, it's really simple to do. You just do escape equals HTML if I'm in HTML context, escape equals JavaScript if I'm in JavaScript context, URL. It doesn't have a CSS escaping because there isn't a CSS escaping, really. Different parts of CSS need things escaped in different ways. So don't put user data in CSS. And just another example, an HTML template is just as, template toolkit. Most of it's just as easy. You just pass it through the escape filter, URL filter. It doesn't really have a JavaScript filter that I'm aware of to put things for JavaScript literals. And again, CSS tricky, don't do it. And if you have to deal with HTML coming in, like we mentioned earlier, come up, again, whitelist, don't blacklist. Say, I will accept these HTML elements, not just these elements, but these attributes on these elements, and then go from there. As you need more things, expand the list and go like that. But be very, very strict at the beginning, and then you can loosen things up as you go along. But don't blacklist, whitelist. And even if you do that, it's still hard because HTML is a very loose thing, a very loose concept. Browsers accept a lot of crap. So just because it's not valid HTML and you've made sure that you've reduced it to a subset, there's still a possibility a browser will interpret it a different way. And just for like your attributes, never accept JavaScript links in your HTML on something events like on click or whatever. Are these readable from back there at all? No. Okay, well, I'll just go ahead then. All right. The next avenue of attack is CSRF, cross-site request forgery. This one took a while for people to understand because it's kind of weird. Because you're not attacking the service, the provider, so it's not like an SQL injection attack, and you're not directly attacking the user from your service. It's kind of the user is attacking themselves through your service in a weird way. So basically what it is that the user's browser trusts the content back and forth between a site. So one site cannot interfere with another site, but one site can trick the user into doing something on another site without the user knowing. So it exploits the user's trust in, say, the example, the main one that I use is this Amazon.com. So Chris Shiflett was a security author, or is a security author, who found this CSRF hole in Amazon.com. If you visited his site and a certain page on his site, his book would be added to your Amazon.com cart, or one of his books. He could have taken that further and make you buy his book just by visiting his site on Amazon because of Amazon's nice little one-click buy thing. So if you had credentials stored in Amazon, your credit card stored in Amazon, he couldn't steal your credit card information. He could just make you buy his book. So that's the way CSRF works. Like, he didn't grab your information. He didn't steal anything to you. He didn't attack Amazon. He made you do something on Amazon. And it can be done in a way that's hidden from the user. So again, you didn't notice this when you went to his site. It just happened in the background. So one of the ways to, does anybody know, I mean, I could kind of explain how it works, but for instance, say you went to his site and there was a hidden, or a form, invisible form, hidden form on his site that when you visited it, there's a JavaScript thing that would submit the form in the background to Amazon. Your browser would send your login cookies to Amazon, so if you're logged into Amazon, which people stay logged into Amazon, Amazon would just accept this request to add the book to your cart, send back the request to the browser. No big deal. The browser's not going to show it because it's happening in the background. It could be something like an image URL that is actually a form submission, or various things like that. So one of the ways to prevent CSRF is to block on this referrer header, this misspelled HTTP header, refer, and make sure that anything that does any kind of action has to come from your site, or so people can't add something to their cart from some other site. This isn't always possible. Sometimes you want people to be able to come from another site and do some sort of an action on your site. But if you can prevent it, block on this refer. Now, there's some things, Flash can be spoofed into setting the refer, and IE doesn't always, IE6 didn't always send the refer in the right places. But didn't I say earlier that never trust the user input? So how can you trust this refer header? Well, it's just the nature of the way CSRF works, because remember, the user is being tricked to doing something himself. So the user is never going to spoof their own HTTP headers. Their browser could be, again, buggy or corrupted in such a way that maybe they have a virus on there that will spoof HTTP headers. But then again, you're not required to maintain the security on their machine. So it's their machine doing something stupid on their behalf, and there's only so much you can do to prevent that. Another way to solve CSRF, if you can't use the refer because you need people to be able to come and do things like this, is to use these one-time unique tokens. Or not one time, but limited time unique tokens. One time if you can do it. But basically, every form submission needs one of these tokens that your server then provides and fills in on the form, and then that request from that form is valid for a certain amount of time for that user. And the way this blocks CSRF is that when I have this page on my site that puts my book in your cart, I don't know what that token can be. There's no way for me to get that from Amazon to include it on my form to then send back to Amazon. Amazon creates these and puts it in their forms. So that's how you can block CSRF that way. It usually requires a bigger application change because your forms need to then generate these tokens and put them in. And there's always a usability problem, again, with security of if I expire it too quickly, then it's not usable. Maybe it took them 20 minutes to fill out this form. Or if I let it live too long, then it is something that somebody can steal and use later. So there's always that trade-off. There's modules on CPAN that'll help with this. A lot of web frameworks have this kind of thing built in where you can generate these CSRF tokens and then use them for validation. So another form of attack is denial of service. And this is basically just having flooding your service in some way that it brings it offline. So no data stolen, data is not corrupted, it's not like that, but they just bring your service down. So you lose money or you lose your user's confidence or something to that effect. There's a lot of, it happens more and more these days, especially distributed denial of service, which I'll get to in a second. But it can be done in a couple of different ways. One, just lots of really small requests, which is harder to do for a normal person, a single person with a single machine, or maybe a dozen machines. So you can do things where it's just massive amounts of data in single requests. So massive post uploads, things like that. Or requests for seldom used resource-intensive URLs. So this report that you generate once a month that can take a long time to run, 30 seconds to run or so, which isn't a big deal once a month when somebody goes to the site to request it, but then if the URL somehow becomes the target of an attack, it can bring your server down because now 100 of these requests is actually a big deal.
You know what that bell means?
No. Tea time? I don't know. I'm not quite sure. So denial of services, specifically from like a small number of attacks, can be just identified at the firewall level or the networking level, blacklisted. and then you can go along your way. So there's lots of different things that you can use. There's built-in tools for Linux that'll do this. I'm sure Windows has something that you can buy from someone to do it, or the router, the firewall can handle this kind of stuff too. If you want to put it in Apache, mod security and mod DOS evasive can do some limited stuff there too. But if you're really being attacked at the denial of service level, you probably want to do it at the network level, because then if you just do it at the Apache level, then other services that aren't behind Apache could be affected too. So again, this just touches a little bit on the developer. Mostly that's a sysadmin kind of thing. Going into distributed denial of service is even worse, because it's not a single source of the data in the attack. It's coming from all over the place. And if they're smart, they're making it look exactly like your regular data. So, for instance, a distributed denial of service attack against Google would look like a whole bunch of Google searches. And Google wouldn't be able to tell the difference between good and bad, mostly because the distributed denial of service happens because lots of people's computers are infected with malware. So it's coming from people who might legitimately be using your service anyway. So you can't, blocking that person would also block their legitimate use of your service. And yeah, again, you can't really tell the difference between a DDoS attack and your service just becoming tremendously popular. So there's some hardware you can get that tries to do heuristics and a good job of kind of detecting these, but they have a lot of false positives. There's services you can hire that do the same kind of thing. They're a little bit, or a combination of both. And the services are kind of nice because they can track botnets, so they know known botnets, and they can see when attacks might be coming and that kind of thing. And these kind of things are becoming more and more popular. Not just, it used to be that a mafia would control a botnet that could attack a service and demand some extortion money. Gambling or porn services was pretty popular to do against them because they didn't really have a lot of other avenues to pursue, so they just pay the money and then not be attacked. But it's also being used by a lot of hacktivists to attack companies or organizations they disagree with. So the scope of who is being attacked by a distributed denial of service is growing. Having a good relationship with your ISP can also help, because then they usually can deal with a lot more people having these kinds of things, and they'll notice these patterns better and fight against them better. Tarp hitting is a new thing that's kind of coming out to protect against these. Some tools in Linux to try to do this, but basically what tarp hitting does is if it notices a lot of traffic coming from a person, instead of, we'll just hit a single machine, so it'll do this for each of those machines. But it'll slow it down. It'll say, hey, chill. Here's the data coming in just a bit. Wait on the data. So basically, a user, you have a really slow network. And maybe it's not, they are really just doing a whole lot of things on your site in the middle of a distributed denial of service attack. They'll get slowed down for that. But a lot of your individual users and good users can still make it through. But again, it's kind of a new thing. And I don't have any experience directly with that. So if you do need it, research into it and see how you can best do that with the tools you have. Buffer overflows aren't a real thing that we think about a lot in Perl because we're running on a virtual machine interpreted code. So we're not writing a lot of C most of the time. But a lot of the modules you use will be written in C. The Perl itself is written in C, so the Perl P5P deals with buffer overflows, protecting against those. So, if you have to use some C, pick something that's tried and true and it's been Perl. Some graphics libraries and open source and people through Lent tools and things like that to try to find these buffer overflow problems. I know Andy Lester did a lot of work with Perl and Parrot to get some commercial open source tools to do some security scans to find potential buffer overflow problems and things like that. So it's not something you really want to do yourself, unless you're really into C hacking and you've been doing it for a long time and understand how that works. All right, so not talking about those basic attacks, but other different miscellaneous things that we can talk. Don't ever try to create your own encryption algorithm of any kind. It's going to be so easy to break, so wrong. These days, encryption algorithms, hashing algorithms, and things like that aren't created by a single person. They're created by people competing against other teams of really smart forth. And this room is smart enough to do it. No, I suspect is smart enough to do it on their own. It's really hard, so don't ever try to do it. Let me know what project you're working on that with. Never, ever, ever store passwords as plain text. If you ever use a service where you can say, I forgot my password, send it to me, run. If they ever send you your password, something is really, really wrong. They should never be able I mean, most of the time, the best recourse there is to reset the password. Let the user reset the password. But if they can give you back your password, then it's busted. So modern systems should do what are called hashing or encoding, one-way hashing algorithms. So you're not encrypting the password, because if you encrypt it, then you can decrypt it and figure out what's hashing it so that the system doesn't even know what, it just has this hash, and then when the user gives the password again to log in, I rehash it and I compare it against each other. Now, I don't know if you guys are familiar with the recent problem that happened with LinkedIn, where they were hashing their data and their passwords, and they got stolen, and people are working through the passwords and cracking them again, because LinkedIn wasn't doing passwords. Salting is basically creating a random string of the password to make it so that you can't just use the same hashing algorithm to figure out every password. Because if you're familiar, in this whole mess about LinkedIn, I'm sure you might have, if you know about that, you've heard the talk about hashing and salting and maybe rainbow tables. Rainbow tables are pre-computed hashes of lots of different strings, which take a long time to generate. I think a 6-password rainbow table on modern GPUs can take about 5 or 6 days to create. So you spend, 6, if you do 6 and then 7 and then 8 and it goes up. And that's just alphanumeric. So if you add all the characters, it can take weeks, months, years to create these rainbow tables. But once you have them, you can then decrypt a whole bunch of or reverse engineer the hashes of lots of data. So people would have these rainbow period of time that then they can then use to reverse engineer hashed passwords. And that's where the salt comes in, because the salt is per password, and that means the rainbow table needs to be per password. If it takes me, just on the very simple level, 5 days to create a rainbow table for a single password, how effective is that against a malicious leak? It's 5 million days to create rainbow tables for 6-character passwords. So hashing is a per password thing, which means the rainbow tables have to be per password. But even better is to do something that'll do multiple iterations, because you want to slow down the creation of rainbow tables. And if you password 1,000 times, then each individual longer or each hash is going to take longer to compute. On an individual basis, your user is not going to notice a difference. Somebody running a GPU cluster to create a rainbow table will notice a difference. So the best thing I can suggest is to use something like crypt PBKDF2, which is a specific kind to do this with. Normally, you don't even want to use something like an old hash algorithm like MD5. You want to use SHA-2, not even SHA-1 at this point. But if you run it through an algorithm like PBKDF2, sorry, that takes me a while to say, you don't even really need 5 at that point, because it's salting it, it's iterating it 1,000 times, it's going to protect it. So use something like that. That'll just handle all the details for you. The algorithm's been tried and true. It's a horrible name for an algorithm, but it works. I know a lot of you existing applications, and you may be storing the password in plain text. You may be hashing the password without a salt, or you may be salting it but not doing multiple iterations. So it's an interesting problem is how you upgrade that data, because if you're doing it right, if you're storing the password in plain text, or maybe even just encrypted, then it's actually pretty easy. You just start hashing it and then drop all the plain text versions of it. Have a hash of it, you can't get the original password from that hash, unless you build your own rainbow tables, and that's just a mess. So what you can do is just create an extra field in your table, rename the one to be old password, and then have a new password field. And as a user comes in to their password, and then you verify the hash, then you can then password to the new hash using your new EKDF2 and store it and then drop the old one. So your users, as they use your service, will upgrade their own individual passwords. So it's a way to get around that without having to, or a way to be able to upgrade your system. Another tip, avoid leaking information. I know everyone has a website that can't handle the load or whatever, and it's PHP, and you get the standard PHP cannot connect to the database error. And it'll give you lots of information about what database, and or potentially a lot of information about these kinds of things. And these kind of information leaks give people information about, oh, he's running this old version of PHP that's available that has this exploit. Well, that's easy. I've now got their system. So avoid leaking this kind of information. I know a lot of people are scared of tailing a log and would rather get an error message on the screen that explains. A lot of people use like CGI in development. Make sure you don't go to production with that. And it's just easier. If you learn to tail a log, it's pretty simple to avoid that kind of thing to begin with because you don't accidentally leave it in production code. Things about this, you should look at the Perl doc, the Perl security documentation. So specific things about Perl. If you're writing script that can be run by users without certain privileges and you want to protect against certain things, and you need, you got to switch users at some point and switch back, and there's a whole bunch of security concerns with users running things with restricted privileges and things like that. But lots of other things too that I'll talk about. And for web application stuff, Open Web Application Security Project, OWASP.org, has lots of tutorials, lots of interesting little filters. There's even some security tools you can find in various places, injection attacks against your site, and see if they can. Those kinds of things are fun to play around with. And if you need to do security scans, you can automate that kind of thing too. So, any questions for anything we've talked about? Anyone have any nice wars for the sake of? Yes. Yeah, that's kind of the. For those watching at home, he talked about they were attacked by a distributed denial of service attack, and they noticed patterns. They were able to then use mod rewrite to 127.0.0.1. In fact, attacking themselves, found out where the attack was, pointed it at the marketing site, distributed denial of service attack back, and killed them. And that's actually kind of, I mentioned tar pitting earlier, and that's a neat aspect of tar pitting because tar pitting can bring the individual bot machines to their knees because they're trying all these different HTTP requests and then they're just waiting network information to come back from you, and you're just, I'll give that to you later, over and over again. And so those bot machines can actually pretty much die from this reflected attack, which is, I think, the best way to fight against these distributed denial of service is to, instead of try to deal with it yourself, is to reflect it back onto them. So, any other questions? Thank you. Yes, the slides will be available on the wiki. I'm going to post them on the for the talk on the wiki some point today.
Mike, that was a great talk.
Thanks. It's always a little tricky because some of you have to understand how the attacks flow, and that's not the easiest way to. I should have had some diagrams showing how it works, but
diagrams would be a little better if we could do it again.
yeah.
I think with some of those, like the
I'm sure OWASP has some
request form where you're reading the narrative instead of seeing the picture of it.
Yeah.
Is a little more difficult, but I think for a 101 is a great job.
Thanks. Yeah. trying to. It replaces like the normal Unix crypt, right? And it's one-way hashing. Right. I still think. I'm trying to think if that does everything you're supposed to do with salt and multiple iterations. And I don't totally know what it does.
I know it has the random salt, so it can
Yeah.
it's random. But the cool thing it has is that you can tweak it so it becomes more expensive to do the.
That's part of the iteration stuff. Yeah. Okay. Then yeah, it probably does both of those. It may actually use that other algorithm behind the scenes because it's an algorithm that's not specifically tied to any hashing function or anything like that. It's just a way to salt and iterate and things like that. So, yeah.
Okay, you know about BobbyTables.com, right?
I should have brought that up. Yeah, that's a good point. It was a great example about how.
Okay. Would you please write something up, because all the sources on GitHub for Bobby Tables, write something up that is an explanation of the timing routine. Okay. Because I've never even thought of that before. I think that's brilliant, and it's a clever idea that, people can, just show. I'm trying to get across in the overview that SQL injection is bad. It's not just this one thing.
Right.
There are all kinds of